I'm going to repeat once more time the fact and dimension that we touched on the last working day. So fact is the measures one that can help the numerical values to be isolated. So if we question on top of how much or how many on top of data, whatever answer I'll be receiving, it's a quantitative in nature. It's also called measure. So just like revenue, cost, number of accounts, this kind of fields can be always said a fact. Okay. So while decorating data in the fact table, we should maintain all those facts and the foreign keys over here. Foreign keys, then the different facts. In dimension table, if we question on top of data, who, what, when, where, whatever answer we will be receiving, that is dimension. Okay, just like customer, product, time, date, those are called dimension. So each of the dimensions, for each of the dimensions, we are storing the data in dimension table. Just like the store dimension is having store key, store name, street address, city, state, region, country. Product dimension is having product key, product ID, product name, product group, brand, department, etc. Okay, so you can see each of the dimension table is having their own primary key. Okay, now just recall the thing. In fact table, we are putting all the foreign keys of the dimension. So when we will be creating data modeling, the same thing I'll be repeating once more time. Okay. Now before starting the data modeling part, I'll be going ahead with some more insights on top of fact and dimensions. Those terminologies are very important. Okay. First of all, grain and granularity of fact tables. So what is grain? Grain is the business definition of a fact table's row. It also defines the measurement event that produces the fact table's record or row.
Comprehensive.
Okay. So whoever has joined, I think Saimek, this is your first class, correct? So if anyone is joining and covering their first class for today, please go through the old recordings available in the Tetra Data YouTube link. Okay, and continue the sessions. If there is any stuck point, any obstacle is there, please ask me question after the class. Okay, so we are there in the grain and granularity of facts. So during creation of the fact table, we need to think, or the architect need to determine what should be the grain and granularity of the fact table. So what is grain? The significance of a single record is called grain. Let me show the thing with an example. Okay. So here is an example. It's a fact table. Okay. So in this fact table, you can see the quantity and amount is the transactional data only, or called fact data. Fact. Apart from that, we are having store ID. Store ID is nothing but a foreign key, which should be a primary key in a store table, store dimension. Item code. Item code is the foreign key from the item table or product table. Date key. Okay. Bill number, sale ID. Bill number is also maybe a foreign key, and sale ID is the primary key of this sales table. This is a sales transaction table, which is a fact table. So you can see there are only two transactional data. That means two facts information. Rest of the things, the sale ID is the primary key of the same table, but the rest of the things are foreign keys. So the grain I can tell when I'm defining the grain, I need to define each of the foreign keys which have been contributed from each of the dimensions, just to have the relationship between the transactional data or fact data against how many dimensions are getting involved over here. So you can tell each of the records grain is sales transaction per store, per item, per date in a bill. Okay. So this is called grain. In a single line, I can describe what is the what a particular record signifies over here. Okay. Similarly, I have another example. Over here, it's a result. Okay. In the result, we have marks. Marks is only the fact over here. Apart from that, everything is, it's not exactly surrogate key. You can see they're directly putting the dimensions from each of the dimensions. They're not putting student ID, but they're putting different dimensions. But it can also be a factable, but the standardization is not maintained over here. Just like over here, we need to put subject ID, and there should be another table for subject ID and subject. This thing should be student ID, and there should be separate table which should be consisting student ID and student name. But just for the reference of understanding the grain, I maintain in this way. So what is the grain of this table? Marks of a student got in a subject in a particular exam, in a batch, in a particular year. So this is the only transactional data or fact data. Apart from that, what are the different dimensions are getting involved? I need to mention those names in the grain. Okay, so grain is nothing but what it signifies for a single row. Now, what is granularity? I'll be moving to granularity. Granularity means how much detailing level we are mentioning the data in the fact table. Okay, if the data is at the transactional level, okay, it is called the atomic level data. Mean the most transactional level means the more minute level we are storing data in fact. This is called atomic data. And the low granularity level, it's the summarized and aggregated one. I'll be showing this thing in an exercise. I mean, on a particular example later. Okay, let me show this now. So just remember what is granularity, how much granularity level we are maintaining in a fact table. That thing we need to decide first. Even I want to show you how grain and granularities are interrelated. Okay, let me take the example of this student. Okay, so suppose it was year, batch, as a section. Let me put class. Let me put uh, name, semester, subject, marks. Okay, so this should be our columns. Over here you can see the same thing. The marks is the only fact or transactional data, and those are the different dimensions I'm going to be involving over here. Okay, so marks can be, okay, let me put individual things. Suppose year is 2021, name Raj, semester first, subject computer application, comp A. I'm putting in this one. marks. How much marks? Suppose 85. Okay. 2021, the same person, first semester. Let me put operating system, OS. See, 78. Okay. Another person, Naveen, first. This is second semester. Sorry. Okay. Suppose this is a data set. So the data set, how I can define the data set? Marks for a particular subject, the grain I'm telling. Okay. The marks in a subject, in a semester, for a particular student, in a particular year. This should be the grain. Okay. Now I can change the grain. Suppose if I change the grain, just think about we are also changing the granularity. Okay. Suppose I'm going to delete this field. So our grain will be affected. Our new grain, in our new grain will be not be involving subject dimension. Okay. If I just delete this, let me hide it. If I'm going to hide, then you can see this thing is duplicated. 2021 Raj first semester is having 85 marks. The same thing, it's 78. This is a absurd one because first semester 85, first semester 78, it's a absurd one. That is why we need to summarize. Okay, so new data should be looking like in this way. These two records should be summarized. As subject is not there, let me delete subject. So there should be single row. 2021 Raj first semester I'm deleting. I need to add 85 and 78, which should be 163. Okay, so this row will be deleted. Similarly, for Naveen, these two things are same as per grain. So I need to aggregate the thing and put it in a single row. And those things are fine. So let me just discard these things and put it over here. So you can see tables row number has been decreased, but the facts are maintaining well. There is no issue with the fact data. So over here, the grain is marks per semester per name per student. Sorry, marks per semester per student per year. Okay. So we have changed the grain. Semester is, subject is no more there. Okay. Subject was there earlier over here, but subject is no more there. We're affecting the granularity as well because it is aggregated data. It's not a fully granular or atomic level data because maybe my principal can ask, they are just checking or analysis the result for individual students as per semester. Now principal can ask the questions. So the semester marks what is the subject? I mean, which based on which subject they want to analysis based on the subject as well. But subject is not involved over here. That is why marks are not getting splitted into multiple line items. Okay. Granularity means how much detailing level we are capturing the data. Okay. So if a particular, if in the grain a dimension is getting added, then the particular data set should be much more granular. Okay. Just like in this case, subject is involved. That is why the line items has been increased in fact table. Subject is omitted from here. That is why the line items has decreased and we aggregated the marks result. Okay. We also decrease this one semester. If I delete semester, then these two again will be aggregated. In 2021, Raj received how much marks? 163 and 93. It should be 256. Okay. Naveen, 158 and 93. It should be 251. Okay. If we remove subject, then again it should be aggregated in this way. In the whole year, the particular student received these marks. Okay. We are affecting the grain as well as we are affecting the granularity. Now share me some different way. Suppose this is the thing. I want more granularity from that of this one. How much granularity I can achieve? Suppose from this subject, I want to segregate. I want to see whether the particular student is good at analytics level. I mean, maybe in practical level or theoretical level. So then I can introduce one more column or one more dimension. Just like this should be exam type. Okay, exam type. Whether it should be practical. Each of the line item, again, it will be splitted. Let me show you. Theory, practical. Okay, suppose 85 will be splitted, then maybe 60, 25. Okay, this is the way we are going at, we are introducing one more column for a new dimension and the fact is getting splitted. We are capturing the data with some more granularity level. Okay, I hope this is clear, but if it's not clear, please tell me or ask me questions. I think it's clear. The relation between grain and granularity, how one is affecting another. Okay, so now based on the product owner or architect decision, we need to think about the granularity level, grain and granularity of a fact table, because fact table is very, very important. This is the main transactional table. On top of this, this is the main responsible table. We are creating the charts and graphs. We are showing them the KPIs, the proper fact values there. Okay. The main transaction are getting stored over here. So how much detailing level of fact information they require? We need to, check that thing with the product owner or maybe the architect or maybe the visualization team member. What kind of relationship they are going to establish during creation of the charts and graphs. Okay, based on that, we need to maintain our fact table. What should be the column name? Then we need to declare the DDLs to create those fact tables. Okay, I hope it's clear how a fact table can be designed. Just I'm going to give those details of grain and granularity. Maybe at the project, you were told to create a fact table with having this grain. Okay, just recall these terminologies. Just remember these terminologies so that when they will be asking to do the so, there will be no stuck point from your side. Okay, the dimensions are very simple. Actually, dimensions. It should be the particular ID. Suppose if I just replace the thing in a dimension, I haven't. This is not a proper foreign key of the dimension. Over here, just like this can be a subject ID. Okay. In a particular dimension table, I can mention subject ID and name in this way. Okay. ID I can put this, this, this way. Okay. Even semester ID, student ID. So we can maintain separate dimension for the same and call the surrogate key or this primary key, put it over here. Okay. So dimensions, we can elaborate some more columns based on which dimensions. Based on the relationship in the particular KPI or dashboard, which kind of relationship I want to see over there. So I can include more columns there. There should not be any issue. Based on the data requirement, we can introduce those things. Okay. Now the next point is from the dimension I want to show you slowly changing dimension. This thing I also mentioned in the last working day. Dimensions data, dimension tables data are very slowly changing in nature. Even the data volume is very less in dimension table comparing to fact table because the fact table is consisting all the transactional level data and dimensions can be static in nature for few days or few weeks based on what kind of dimensions I'm going to introduce. And if the change is also there, the change is very slow. But to track the slow changing dimension, we are following any one of the type. Either it can be SCD type 1. SCD means slowly changing dimension. The dimension, while storing the dimension value, it can be SCD type 1, SCD type 2, SCD type 3. Based on how we are keeping the history of the dimension. Let me share my screen with an example. Okay, let me close this one. Okay, so I just prepare some examples over here. So the first example is SCD type 1. We have an employee table with us. It's a dimension table, so employee ID is the primary key and the other attributes of the employee. That means employee name, employee designation, those are fine. Those are the other attributes of the table. Employee ID is the main primary key and those are the other name and designation and the other attributes. Okay. Now think about it. A particular employee's designation has been modified. Okay. So suppose this one ABC, the first employee, employee ID1 ABC. Yesterday the employee's designation was trainee. Today his designation has been updated to developer. So today we can store the data in this way. Whatever current data it is for each of the employee, we can store it in the dimension. Okay. But suppose the question may arise whether the particular employee has joined the company directly as a developer or he has joined as a trainee. because this kind of scenario happens. Some people switches from different company and join, and some persons are there in the company from the very beginning. They joined as a trainee and they are getting promoted with one by one promotions. Okay, so this question may arise maybe based on that some I mean rating system can also impact on top of this. They give some priorities for the existing employees than that of the persons who came new. Okay, so this kind of thing. So if we store in ACD type 1, we cannot determine this kind of questions answer. Okay, so for that we need to introduce some date. So ACD type 1 is the simplest kind of dimensions where we are not storing the history, or by checking we are not able to understand if there is any change or any modifying of each of the attributes. If I need to capture these attributes, that is not possible in ACD type 1. So for this thing, we can introduce ACD type 2. Okay. So over here you can see with that thing I am introducing another date. Okay. So the date is transaction date, means which particular day the particular shift has been happened. Just like this one, we are storing this information, as well as if the particular employee's designation has been promoted, we are introducing another row. Okay, and the transition date we are mentioning over here. This way we can create ACD type 2. Based on the requirement, we need to determine whether this should be ACD type 1, ACD type 2, ACD type 3. It's totally based on the requirement, what kind of attributes I want to see. If this is not a necessary one, means this kind of transition date and all, it's not a necessary one for our calculation, then we can simply follow ACD type 1. If this kind of thing is required one, then we need to introduce this kind of transition date. Okay. Now ACD type 3 is there. Over here we are introducing rows. And I mean the existing row was there. Along with that, I am introducing another new record. ACD type 3 is a bit different. Over here we are not increasing the records anymore. This way the record number will be increased. For an individual trainee or individual employee, there should be multiple number of records. For these cases, for type 3, we are introducing one more columns to get rid of the increasing of number of rows. Okay, so we just introduce the date and previous designation. Okay, so you can see this is the data till the ACD type 2, and I'm also maintaining the last previous resignation for each of the employee. Okay, just like employee ID1, ABC, current designation is developer, transition date is this, and the previous designation also maintaining over here. This is kind of called SCD type 3. We're increasing the number of columns, but this kind of repetition of same record we are not accepting over here. Okay, so the same thing I'm telling, based on our project approach, which particular dimension we need to design, we need to check this thing, and we need to go forward with the design or development part of the dimension. Any doubt so far for SCD examples? Yeah, hi, because
In the type 2, like the employee ID, I mean, it is repeating, right?
correct.
1.
We are repeating
So,
while storing the data, we are repeating it. So employee ID is not a primary key over here. Only employee ID is not a primary key.
okay.
Maybe the combination of employee ID and employee designation. It
Mm-hmm. Okay, okay.
it can be a primary key. Okay.
Yeah. Got it.
Combination of that cannot be duplicated. Okay. Okay. So SCD type 1, type 2, type 3, this is very, very actually important concept. Please also go through this topic in detail with some more examples from website as well, because interviewer are going to ask these questions. Okay. And based on totally your requirements of the project, you need to design either one of the dimension, especially the small dimensions or this particular dimensions which are not very much significant in nature. We follow SCD type 1 in our project because this is the simplest one. You can store it. But suppose in the dimensions we need to maintain the history based on the requirement, then we need to go ahead either SCD type 2 or SCD type 3, any one of the thing. Okay. Moving to the slide. So just we have some insights on top of dimensions, facts. Now, when our facts and dimensions are ready, then we can create this kind of data modeling. In this data modeling, you can see we have a single fact table, means this is a transactional table. Fact table is having those columns. And again, you can see starting from the beginning, it is nothing but the foreign keys, time key, product key, store key. Each of the foreign keys are the primary key of each of the dimension. Now you can see the surrounded tables are nothing but the dimension table. This is time dimension. This is store dimension. This is clerk dimension. This is promotion dimension. This is product dimension. This is customer dimension. This is registrar dimension. Okay. So each of the dimensions, they are having their own primary key, and this primary key is over here are presented as a foreign key just to maintain the relationship. Okay. And apart from that, in the fact table, the main transactional informations are dollars sold, units sold, dollars cost. So those are the main fact informations. So this way we can convey multiple things. We can convey the grain of fact, granularity of fact, how much granularity level storing the data in the fact, means how granularity levels the line item should be in the fact table. And we can also, suppose I need the particular customer's details with that particular transaction. Then I can quickly join the customer dimension based on the customer key and what are the different attributes are available for the customer dimension. I can get the information against each of the attributes with this transaction. So the data modeling is very, very important based on what should be the joining keys, what are the different attributes we can make relationships. So those kind of informations, everything we can confirm by checking a single data modeling page. It's also called dimension modeling, ER diagram. Okay. And this is very, very important thing for a data engineer. You can say this should be designed at the very beginning level. How should be the data modeling? How many dimensions should be involved? What should be factable transaction? They create this thing first. The blueprint is created for the beginning first. Then the other thing should be started. Means fact creation, dimension creations, uh, how the fact and dimensions can be loaded by the ETL tools and all. So it's kind of a top-down approach. First, we need to create or think about the data modeling. Okay. And then that should be the data modeling. That columns we required at the data warehouse tables. Then we are checking at the source system what are those columns we are pulling from there to here. Okay. Data modeling is also required during design of the BI tool means, especially the data analytics tools or visualization tools. So if you are designing, anyone is interested at the visualization tool, just like click Power BI Tableau over there, you can see the data modeling is one of the important concept. We need to create the data models. If we do not create the proper data models, suppose I want to set a relationship between product brand versus each individual brand is having how much sold. If we do not have a proper relationship or ER diagram, we cannot set up a proper data in the dashboard. I'll be showing this example while I'll be showing the Power BI concept. Okay, Power BI is our visualization tool in our code. So we'll be showing this thing in one of the classes, how data modeling is playing the key roles. Okay. Now, while designing the data modeling, we can face, there are two major aspects. The data modeling can be following a star schema concept, or the data modeling can be follow a snowflake schema concept. So what is star schema and what is snowflake schema? Let me show you. Okay, you can just quickly read it out. The star joint schema or star schema is a single factable joint to a set of dimension tables. It is named as star schema as it resembles as a star. In a star schema, a central factable is surrounded by multiple dimension tables. Each dimension table is having its own primary key as a foreign key in the factable. So this is the design of the star schema. Over here we have a single factable just like stores, and it is been surrounded by multiple dimensions. Each of the dimensions should be having relationship with the factable with the primary key and foreign key concept. Okay, hope this is clear. There is no issue. Now, what is snowflake schema? Star schema is the simplest one. Okay, but in our project, we especially do not want to put direct relationship all time with fact and dimension. Just like over here, you can see the brand category, those dimensions does not have direct relationship with the fact table. Okay, fact is having direct relationship with this product dimension, geography dimension, customer dimension, organization dimension, and time dimension. Brand and category, those two dimensions doesn't have direct contribution or direct relationship with dimension table. They are joining with the other dimension table. Okay, because maybe there are no direct contribution of fact. I don't want to make a grain concept with this dimension. Okay, so based on variety of reason, we need to think about whether this should be a snowflake schema modeling, data modeling, or star schema data modeling. Okay, so this is also very, very important concept, and this question may asked from the interviewer, what is star schema, what is snowflake schema? They'll be also trying to, ask you those questions. So please check these things from the web as well quickly, because this is very, very important. What is the difference between star schema and snowflake schema? Okay, now moving to ETL. ETL in basic things we learned on the last working day. ETL means the particular jobs or particular tools which are loading data from source system. Source system means OLTP systems. What is OLTP? We have learned on last working day. So OLTP is a data source for the data engineers. Okay, so we are storing data from OLTP and we are pushing the data into data warehouse. Okay, so either the data is pushed in a fact table or in a dimension table. In data warehouse, in data marts, in ODS, whatever. Now ETL is the middle portion. ETL job is running daily basis and refreshing the data at the target site. So after the business closure, whatever new data we receives, we are interested to push or see the same thing in our dashboard. So that is why we are running the ETL job daily basis. Not only daily basis, suppose our business is very, very critical. Okay. Suppose I need the data refresh every half an hour based on my client. Okay. Suppose I have an insurance client. It's not very much critical to produce the report within half an hour or just like this. So then daily basis, if it is refreshing daily basis, then there should not be any error or any issue. But suppose I'm handling a critical project. As per the requirement, the data needs to be showed to the business very quickly because there shouldn't be business strategy changes in the very same day. Okay. They need to take quick decisions based on the source data. So that time the ETL job should be run based on that intervals. Suppose half an hour or 5 minutes or 10 minutes based on the business requirement, we need to run the ETL job accordingly. Okay. Now, what ETL jobs are doing apart from loading the data? In ETL, the abbreviation is there. E for extract, T for transform, L for load. So, ETL jobs are extracting the data from the source system. It is transforming the data. Transforming, what kind of transformation we can do? Just like we can clean the data, we can see if there is any duplicate. First of all, remove the duplicates. This is the first point. We are also cleaning the data. Suppose in each of the column there are some trial spaces. There is some wrong naming convention. As I mentioned, the ETL tools, the first step of the ETL tools, they are taking data from various source systems and pushing it to a single stage layer. So there we are not doing any kind of cleansing or any kind of transformation. We are just storing whatever it is at the source system. We are copying and pasting the same thing in a single stage area. But when we are loading the data from the stage area to data warehouse again, that time we need to clean the data. We need to transfer the data in proper way. Okay, suppose I have an insurance company and I have lots of countries are my client in Middle East areas or just like this. Okay. But for each of the Middle East countries, they should be having their own language. So when we are collecting data, we are getting different languages of descriptions. We are having different currency rates. Each of the countries having their own currency. So that is why the purchasing policies, the coverage, all the things should be as per their local currency. Till stage we are maintaining the currency and currency values. But when we are storing data in data warehouse, we need to analyze it properly. So there we need to make everything in unique. Suppose I'm converting everything in USD while loading the data in our fact table. Otherwise, we cannot compare the thing. Suppose I want to see in my KPI what is the total gross business in the last quarter. If the currencies are in different format, then I cannot implement the direct summation in my visualization dashboard. Okay, because each of them are having their own currency values. So that is why this the transformation layer should be helpful. We can transform the other currency values, the local currency values to USD, and we can came to a single platform to represent the same. It's not only for USD. Suppose there are some varchar functions, but we need lots of date kind of functions. We need to extract date or just like this. So we can convert the varchar to date format. Then we can impose all kind of date functions there, whichever is required. So that is the thing. Transformation is very useful thing Transformation means the T part. E for extraction, extraction the data. T means transformation. We will be transferring the data such a way there should not be any issue. And L for loading part. When our data are ready after transformation, data is ready, then we can load it at the target data warehouse. Okay. And I need to refresh it as per the refreshing frequency. So ETL can be a job, it can be a batch job. We need a scheduler. Maybe suppose we are, working in a Linux project. Okay, in Linux there is a scheduler called uh, cron tab. Cron tab is one of the important scheduler. Scheduler means how we are scheduling it. In Windows system as well, there are task scheduler. If you can check, there is task scheduler. Yes, this one. Suppose we are generating ETL and we are wrapping the ETL in some batch script, okay, in .bat file, and we can call those batch in each of the particular time. Suppose 9 a.m. IST time, this job will be running. 10 a.m. IST, this job will be running. Based on the requirement of the customers, we can schedule the jobs in this way. Okay, so this table will be refreshed in this time. You can set the job dependency as well. Especially we need to load the dimension jobs first, then we need to load the fact table. So dimensions are pushed first. Suppose there are some new dimensions created maybe in the very last day. So we have to insert this dimension first. Then we also need to include the new transaction about the dimensions. So that is why dimensions and fact tables are getting refreshed in a scheduled way from the scheduler. Okay. So this is the ETL concept. And while running the ETL, we are following some strategy, design strategy. So while extracting the data, either it can be a full refresh or it can be an incremental data load. Incremental extracting method or full refresh extracting method. What is full refresh extracting method? Suppose in our source system, suppose we are loading a dimension. Okay. So today the dimension is having 50 records. Okay. So while loading the same thing at the target, we can load it or we can extract it in two manners. One is full data extraction, means whatever data is there in the source system, I can directly push it to target. Now think about it. Yesterday we have also some record at the target system. Suppose yesterday we have 48 rows. Today we received two new rows. That is why today it's 50. Okay. So if we do full refresh from source system and push it to target, then we need to truncate the data at the target because there should be duplicated. If we keep the previous records as well as the full refresh record at the target, then the data should be duplicated in the target side. So while we will be going ahead with the full refresh, then first we need to truncate the target table and we can go ahead with full refresh, full insert. Okay, so I'm also maintaining the loading strategy over here. If we maintain a full extraction from the source system, we need to truncate the target system and load it, load the entire data set. Okay, but suppose we have a fact table loading and the fact table is having billions of records. Daily basis, all the transactions, maybe millions of transactions are there happening in daily basis. And the data is getting increased at the source side as well as target side. For these cases, we should not be going ahead with the full refresh part. because each of the ETL job runs, it will take huge time. So daily basis, if we just going to load billions of records, then suppose each day it took 15 to 20 minutes at the first beginning. Now, as the data volume is getting increased, someday you can see the entire job is taking the duration for 1 hour to be completed. So that is why the new strategy is called incremental strategy. It will only see what are the new transaction at the source side. It will not check the previous day's transaction anymore. Okay, it will be checking what are the new transaction we received. So incremental data load or delta data load is the same concept. We'll be only checking the new rows or the existing rows with some new attributes. Both of the two things they will be checking, and at the target system they will be inserting the data or upsert the data. Update and insert together, it's called upsert. That means suppose some existing records primary key is same, but the other attribute has been modified. Just like a dimension example I told for ACD type 1, suppose the employee's designation has been updated. So when comparing, it can see my primary key is already there, but the other attribute, just like designation, has been modified. This can be one scenario, and there can be another scenario: a new employee joined on the very next day. So a new record has been inserted at the source side at itself. So to handle the existing data which is getting updated, that should be pushed as update format, and the new record, new primary keys will be inserted as it is. So this kind of data loading strategy is called upsert, update and insert. Which records are updated at the source side? The same thing should be updated at the target. And if there is any new employee appears, then that should be inserted. So this kind of load is called update and insert, or in simply it's called upsert. But that is followed when we are going ahead with the incremental data load, incremental data extract generally. Okay, you can also follow insert. We can only insert it. Okay, suppose there is no such attributes modification. We are not maintaining the proper primary keys over there with the employee ID. Then we can go ahead with the insert mode, data load. It's also called append mode, data loading part. Okay, data extracting and data loading strategy, it's a bit conceptual. If it's not clear, please tell me, or I can also show this thing with very next with an example in Excel. Okay, so that the concept should be clear, because this is very important concept for a ETL tool developer. Whoever is trying to concentrate on top of the data loading strategy, on they want to stay in ETL tool developing part, they should be have to clear their concept of data extracting strategy as well as data loading strategy at the target. Okay, is it clear for everyone, or can I repeat it once more time?
I have one doubt, like
Yeah, tell me.
if we are loading the data from the source system to target system, so
Mm-hmm.
basically the target system is the data warehouse, right?
Correct.
So data warehouse, I mean, if we store the data in data warehouse, I mean, it cannot be changed. I mean, in yesterday class, you told that uh, the data warehouse stores historical data, and it cannot be changed. So can we do this I mean, whenever a new employee is add, if the designation of the employees changes, uh, we'll be recording the, I mean, we'll be updating the employee record, or we'll be inserting a new record of the same employee in the data warehouse, or how does it work?
Yeah, I mean, yesterday I told, I mean, data warehouse data cannot be changed means the historical, we are keeping the historical records as well. We are also inserting new records. So suppose any employee's designation has been updated. So if we follow the SCD type 1, Okay, at the target side,
Mhm.
means in the data warehouse, then yes, the attributes should be modified. What I means the primary key should be fixed. Okay, suppose employee ID 1, his or her designation was trainee. Okay, so on a particular day, his or her designation has been modified, and the same thing is represented in the source side. Suppose from the trainee, he is now a senior developer, or just like this. So the same thing I need to update at the target as well. So now the question is whether target wants to made it in SCD type 1 or SCD type 2. If the target is SCD type 1, then I need to update the record. Okay. So based on the primary key, it will be checking the primary key. For the primary key, I mean the primary key is same for that employee ID 1, and it will be checking the other attributes. Other attributes are modified just like the designation has been modified. So for SCD type 1, we are not going to insert a new record. We need to update. Did you get it? But if we are
Yeah,
following
yeah.
SCD type 2 at the target side, then we need to append it. Append the record with a different timestamp, or just like this. So we are not changing means, suppose we are staying with the same primary keys concept. I mean the primary keys are same. But if the attributes are getting modified from the source system, and if we are not following SCD type 2 or type 3, then we must have to change the attributes. Okay. But if we
Uh,
want to make it a historical data, we are following SCD type 2 and type 3. I mean, basically, when you are asking the questions, you are thinking in the mind that we are storing the data in SCD type 2 format. Okay, then whatever you told, it's totally correct. We need to load this thing with the historical information as well as the transition date this way. Is it clear or
yeah,
uh,
I got it. I got it.
okay, okay. And tomorrow, I mean, it's a holiday. So Monday, I'll be trying to explaining the same thing with an Excel. I'll be just showing a data flow, how the data is flowing with the strategy. I'll be showing this thing, okay, with a detailed manner. What is the time? Okay, let me cover one more slide related to ETL. Yes, so I just want to mention this thing. Those are different ETL tools available in the market. Okay, just like Informatica, it's a very important ETL tool. We have Power Center. Nowadays, we are having cloud-based Informatica. It's called IICS. We have Data Stage, which is a IBM product. We have Ab Initio. Okay, in Microsoft, we have also lots of ETL tool based on Microsoft SQL Server. We have SSIS. Okay, so those are different ETL tools available in the market. We have Talent. Talent is one of the ETL tool. Cognos Data Manager. So those are the different ETL tool. Now, product owner, they need to think which of the ETL tool they need to use for their data loading strategy. Okay, but nowadays, I mean the particular licensing cost or the renewal cost of the ETL tool. Actually, when we are using the same ETL tool in our business purpose, that should not be the trial version. That should be very high version, and the charge is very high for each of the ETL tool. And there is also problem with the licensing that I mentioned. Maybe the licensing are getting expired for each quarter or each, I mean, a half yearly. So the same kind of licensing needs to be renewed for each year or each half yearly part. So based on the costing involved nowadays, what I mean, they're thinking not to use this kind of tool anymore. So they're creating some language driven ETL tool. Just like they're creating their own ETL tool based on some framework. Maybe they're creating some Python framework, and by writing the languages, they're creating the ETL tool. When we are using this ETL tool, we need to very much be specific on user interface. We are just calling a table. We can see the table over there. We are dragging the thing. We are dropping the thing in some workspaces, and we are creating the pipelines there. And at the back end, they are calling those SQL scripts and all. Okay. But in a framework driven, we have to code it. We need to parameterize. We need to put the select query by your own or just like this. There is some difference, but nowadays they are moving to this framework driven because this is no more. I mean, a licensing is getting involved. Suppose I'm just going to create an ETL tool based on Python language. So Python is an open source free language that I can download from the web, and there is lots of hosting platforms. Hosting platforms are available in the clouds. Suppose in cloud, suppose if we are aware with AWS Lambda. Okay, Lambda is a serverless, execution of Python codes or just like this. So we can just take some AWS Lambda's help and put some Python codes there, and we can run the Python codes directly from there, which will be working as a ETL tool. Okay, so people are bringing up their own ETL framework by writing the codes in various language. Maybe it's a Python, maybe it's Java, maybe it's a PySpark or just like this. And the ETL is getting generated in this way. Okay, so maybe in Python chapters we will be trying to solve this kind of ETL. We will be extracting information from a source system and we'll be pushing data at the target system in our projects. Okay, so this is the thing till today. Okay, tomorrow I'll be just showing with an Excel how the loading strategy, extracting and loading strategy is occurring, as well as I'll be also showing the KPIs part. Means when our data warehouse is ready, the particular data is ready for the visualization purpose. So what are the key aspects of this? What is KPI? What are different charts and graphs? Those kind of things. I'll be quickly have a demonstration. Okay. So let's connect Monday with some more insights on top of our BI knowledges. Okay. So okay, whatever doubt there is, we can discuss it on Monday. And the new students, please go through the recordings. If you face any difficulties or any doubt, please consolidate these things and we can discuss the same on Monday. Okay. Okay, then. Thanks, everyone. Happy weekend. Yeah, because
Sauchit,
you
I
want to.
mean,
Yeah.
can you share this today's class PPT?
Yeah. I'll be sharing. Let me share it over. Can I share it? Okay. I'm sharing it over here in the chat box.
Okay.
Okay, I'm sharing both BIs. BI is very, very important and it's not very much technical. Rather, we can tell it a functional one. So stop sharing, stop recording as well.